Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about ranking. This topic is based on a tech blog with the title Choosing the Right Candidates for Lodging Ranking, written by the machine learning engineering team at Expedia. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. Expedia is one of the world's largest travel platforms. It offers booking services for hotels, flights, car rentals, and vacation packages. A core part of its business model is to connect travelers with the most relevant lodging options. But when a customer searches for a hotel, Expedia isn't just retrieving a handful of results. It's ranking thousands of available properties and deciding which ones to display first. Why does this matter? Think about how you browse online. When searching for a hotel, you likely won't go through dozens of pages. You'll probably pick from the top few options presented. That means the ranking algorithm has a direct impact on user experience and business performance. A well-ranked list ensures customers find the best options quickly, leading to a higher satisfaction and more bookings. On the other hand, if the ranking fails, showing irrelevant or suboptimal results, users may leave the platform or frustrated by the lack of good choices. This directly affects Expedia's revenue, as fewer bookings means fewer commissions. Ranking hotels isn't as simple as returning a single correct answer. Travel search results are highly complex due to several factors. The first one is that the search scope varies widely. A user might search for hotels in Florida, which includes thousands of properties, or they can be very specific, such as a beachfront hotel in Miami with a pool and free breakfast. The ranking system must understand the user's intent and filter results accordingly. Second, hotels offer multiple room types and rate plans. A single property can have different pricing for room based on size, view, refund policies, and promotions. The system must evaluate not just the hotel, but also the specific room offering to make an informed recommendation. The third one is that pricing and availability are constantly changing. Hotel rates fluctuate due to seasonality, demand, and discounts, making it difficult to ensure the ranked list remains relevant over time. Finally, personal preferences play a big role. Some travelers prioritize price, while some prefer boutique hotels with unique experiences. Expedia's ranking system must accommodate diverse user preferences while balancing the business needs. Given these complexities, how does Expedia ensure users get the most relevant recommendation? Let's explore the machine learning approaches behind their ranking system. At its core, Expedia's ranking system prioritizes customer utility by displaying properties that are most relevant to a user's specific search. However, ranking is not just about relevance. It also needs to consider additional business objectives. Customer utility is determined through implicit feedback. When ranking hotels, Expedia's model analyzes past user interactions, such as clicks and bookings. If a property is frequently clicked, but rarely booked, it could indicate that the listing is appealing at first glance, but has issues upon deeper inspection. Perhaps the price is too high, or the reviews are mixed. On the other hand, hotels with high booking rate signal strong customer preference and are ranked higher. Beyond customer utility, other objectives also come into play. These include monetization goals to ensure Expedia remains profitable, supplier relationships that factor in agreements with certain hotel chains, diversity to prevent search results from being dominated by a few brands, and some cold start scenarios where new hotels with little interactions data must still be fairly ranked. With all of this considered, to predict customer utility effectively, Expedia's machine learning models rely on various data sources. These include search context, which consists of user-specific details like check-in and check-out dates, number of travelers, and location preferences, and also static property characters, including fixed attributes like user review scores, historical pricing, and hotel location. Dynamic property characteristics is also taken into account. For example, real-time factors like availability, promotions, and fluctuating prices, as well as user behavior data, which tracks the past booking clicks and engagements to personalize the recommendation. With all the factors considered to put into the model, now let's dive into the architecture side. Since Expedia manages an enormous inventory of hotels, ranking all the properties in real time would be computationally expensive. Instead, the company employs a two-stage ranking approach. The first stage, candidate generation, filters tens of thousands of properties down to a few hundred candidates, and focusing on broad recall to ensure that relevant properties aren't overlooked. The second stage, final ranking, uses a more sophisticated machine learning model to refine the list and select the most relevant options to display to the user. Expedia has experimented with various learning-to-rank methodologies, ranging from linear models and factorization machines to more complex deep learning architectures. While simpler models offer interpretability and efficiency, deep learning models have proven more effective in capturing intricate patterns within the data. These advanced architectures consider a broad range of features, such as historical booking patterns, user behavior sequences, and nuanced interactions. By leveraging deep learning techniques like attention mechanisms and neural ranking functions, Expedia enhances its ability to predict the most relevant lodging options for each user. These models continuously evolve as they learn from new data and improve ranking precision over time. After looking through the model architecture, next, let's look at the model evaluation. The evaluation process differs between the two ranking stages. The final ranking stage measures prediction accuracy by comparing the ranked results shown to the user versus the user's actual bookings and clicks. Meanwhile, the first stage, candidate generation stage, is assessed using a matrix called recall to ensure the system includes the best possible options. For example, if the model selects 50 hotels from an initial set of 300, recall measures whether the most relevant properties were included in the top 50 hotels selected. A higher recall score means fewer good hotels were mistakenly discarded. So now we have talked about the features of the model, the architecture of the model, and the metrics of the model. By building up this machine learning system, Expedia can effectively offer the right recommendations to meet customers' needs. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how Expedia ranks lodging options to optimize both customer experience and their business objectives. We began by discussing the business problem, how ranking impacts Expedia's success, and the challenges of hotel recommendations. Then, we broke down the data science solution, covering the objective functions, features and signals, machine learning architectures, and the evaluation of the system. This is an insightful blog read for anyone interested in building a comprehensive machine learning system. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.